about. Okay. Basic properties there that we want to not forget those too. But then we'll also utilize, let's see here, some other properties here. So one note before we get into these properties is that these are true. And again, I feel like this may be obvious, but maybe not. So these are true for natural logs, you know. These are true for natural logs, and common logs, right? So that's just when you have just log without a base written, okay? And other logs, and all other logs. Okay. And again, I think part of the reason why I state this is because natural logs, the L and the N looks different, makes it look different than the other logarithms that we've seen in the warm-ups and stuff like that. Common log also looks slightly different because it doesn't have a base number written there. All right, so that maybe can throw students off. They get a little, you know, uncertain when they see those. Okay, so we're going to talk about a generic log base A here again. Okay, just kind of generic log. And it's going to be the log of a product. UV, right? U times V there. Log base A of U times V. Okay? And that is equal to the log base A of U plus the log base A of V. Okay? Log base A of U plus log base A of V. So multiplication within a logarithm, okay, can break apart that product as a sum of individual logarithms. Okay. Sum. So product inside becomes a sum outside. Okay. So as an example, you know, if we have log base 4 of 16x, like that. Well, we have a product there, right? 16 and x, they're being multiplied. And so we can write that as log base 4 of 6, oops, I'm going to write it curly, there you go. Log base 4 of 16 plus log base 4 of x. That's equivalent. And we're like, well, great, Mr. Whitmire, you took something that was together, right? It was nice one logarithm, and you made it less simple by breaking it into two logarithms. But now that we've broken into two logarithms, what can we do with that log base 4 of 16? What is that equal to? It's 2. 4 to what power? 4 to what power gives us 16? It's 2. So we can now eliminate that logarithm altogether and actually evaluate what that logarithm would be. And then we have log base 4 of x, like that. So it's a little more, you can kind of use it to help simplify things sometimes. Another idea, I mean, so like other things you could do here, you know, besides just go ahead and simplifying log base 4 of 16 being 2, right? Again, 4 to what power gives us 16 will be maybe 2. 4 squared is 16. Okay. Alternatively, we could take that 16. 16 is a product of things, right? 16, you could say, well, that's log base 4 times 4. Right? Isn't that true? All I do is just take the 16 and make it, now it's 4 times 4. And then again, we have a product inside a logarithm, so I could rewrite that as log base 4 of 4 plus log base 4 of 4 plus log base 4 of x. Okay. And now we can use those basic logarithm properties again, right? 4 to what power gives us 4? It's what? 1. And then plus, well, that's going to be 1 as well. Okay, and 1 plus 1 gives us the 2, and so you can see you do get the same thing. Just another way to do it. Right. Another way to do it there. Okay, but still using the same idea, all those ideas of logarithms there. Okay, all right, let's try another one. Log base A of u over v. Okay. So if multiplication inside a logarithm translated to addition between the two logarithms, what do you think division will become? Subtraction. Oh my gosh, that's right. Okay. Mind blown. Okay. And so again, we can, do a little example here. We can be like, I don't know, the natural log of x over 2. Natural log of x over 2. So that's just going to equal natural log of x minus the natural log of 2. If you want to put something there. Okay. Okay. One more major property here. Log base a of u to the n power. And really this number 3 property follows from number 1. Okay, it really follows from number 1. Because u to the n is really just repeated, it's just repeated multiplication of u. So, but what it results in is n times log base a of that u. So we can take that exponent, u to the n, and move that out front. All right, the idea behind that is when you have, log base a of u to the n, that's the same thing as saying log base a of u times u times u times u times u, and there's n of those u's, right? Because you're multiplying u by itself n times. All right, well, but we just said with all those multiplications, instead of multiplying inside a logarithm, we can change those to additions. So that's going to be then log base a of u plus log base a of u plus log base a of u plus ... so on and so forth. Thank you. Okay, so on and so forth. And again, there'll be n of those. So you're adding up log base a of u, you're going to add up n of those things. Adding up n log base a of u's is just going to be n times log base a of u, right? You're repeatedly adding. So that's why it ends up being just n times that log base a of u. Okay. So questions on those properties 1, 2, or 3? We'll see an example here real quick. Maybe you'll have a question after the example. All right, let's try this. Log base 3 of 9 to the 5th. Again, this is one that you could do without the properties, right? You guys, I could have given this to you for homework, and it's one that you have the skills to do. The properties aren't necessary, but the properties make it maybe a little bit easier to simplify. Okay. So, for example, that 9 is being raised to the 5th power, so that's like our situation in property 3 right here, right? So I can take that and say that's going to be just 5 times log base 3 of 9. Okay. And at this point, we can kind of go we can kind of take 2 different paths here. One path is just to evaluate what is log base 3 of 9. Right, 3 to what power gets 9? It's 2. So we could just say, okay, well, this is just 5 times 2, which is 10. Or we could say 5 times log base 3, 9, we can rewrite it as 3 squared. Right? And then it's got an exponent, which you can then move out front. So we 10 times log base 3 of 3. And log base 3 of 3 is 1, right? So we can also say it's like 10 times 1. So there's a different, there's options here sometimes about how you proceed, right? About how you proceed. It's kind of up to you how you want to go, all right? So questions on any of that? All right. There's 2 things I want to make sure here, and this is like crucial. There is no rule. There's no rule for log base a of u plus v or log base A of u minus v. Okay? So if you have addition inside the logarithm, you're stuck. If you have a subtraction inside the logarithm, you're stuck. There's no way to break those up. Okay? Multiplication inside becomes addition between two, right? Division inside becomes subtraction between the two. But when you have addition inside or subtraction inside, there's no way to break that up or change it around. Okay? I'm going to say that now, and I know it's still going to be tempting. Okay, some of you may still even try it, right? But there's just no rule for it. We can't do it, right? We want there to be a rule, but there is no rule. There's nothing we can do with that. Okay? We're stuck. Okay. So, how are we going to use these things? Well, let me show you here. So, one way we want to use these is for evaluating. Okay. So I guess, yeah, I'll stick to here. So like uses. Okay, so one is evaluating. We've kind of already been doing that now. Okay, but something like, you know, log base 5, you know, of, I don't know, let's say the square root of 50. Okay, log base 5 of the square root of 50. We can actually simplify this, right? So like, okay, well the square root is 50 then to the 1/2 power. And that 1/2 exponent, what can we do with that according to our properties? We can bring it out front and multiply. So we can make it instead 1/2 log base 5 of 50, like that. Okay. Now, to evaluate the logarithm, log base 5 of 50, we're kind of stuck, right? Because 50 is not a power of 5. But 50 is 5 times 10, or maybe better yet, we'd say 50 is 2 times 25. Okay, and so when we have a product inside our logarithm here, we can make it addition. Notice that 1/2, right? It's like times the quantity, times the sum. So you want to have that the sum there in parentheses. The 1/2 should distribute. If you want to distribute the 1/2, you can. Okay. But since it was 1/2 times the logarithm here, then it should be 1/2 times the sum of those two logarithms when you break it up. Now this is helpful. We can't evaluate log base 5 of 2, but what's the log base 5 of 25? It's going to be, yeah, it just equals 2. So we have 1/2 times log base 5 of 2 plus 2. Okay? And if you want, you can distribute the 1/2 and make it just, you know, like what, 1 plus 1/2 log base 5 of 2. Okay? That's using our properties there. Okay? So you guys try one here. Alright, how about you try? Again, just use your properties to evaluate this. The natural log of 4e to the 5th. So I'll just say the directions here is to simplify, right? Try and simplify as much as you can. Using those properties. Try and simplify as much as you can. See what you come up with here. Stuck, Brian? Yeah. Need some help? Gonna Hulk out here? Don't scare your kids, please.
Or like L, natural log of like what?
Okay. Volunteers, want to give me an answer here? What do we say? We simplify it down to B. No brave souls? No one said, Brian, whoa, all right. Okay, great question. Great question. So, what is being raised to the fifth power in this particular example? Only the E, right? So would it make sense to pull the 5 out right now? No. Okay, so what can we do for our first step, though? Yes. Okay, so natural log of 4 plus natural log of E to the 5, like that? Okay. Now what can we do? We can bring the 5 out front if you want. Okay. What is the natural log of E? Yeah, so natural log, remember, it's log base E. So let me help you out here like this. Okay, so natural log, oh goodness, making it a mess here. Natural log is equal to log base E. So in other words, instead of saying natural log of E, I can just say log base E of E. Okay? So in other words, E to what exponent gives you E? 1. So this is just 1. Natural log of E is 1. Okay? It's just like asking log base 2 of 2, or log base 10 of 10, or log base a million of a million. Natural log is log base E of E. So it's just 1. So this becomes, equals 5 times 1. Oh my gosh, 5 times 1, or just 5. Okay, like that. Natural log of 4 plus 5. Did anyone simplify any further than that? The only other thing I could potentially see you doing here, whether it's helpful or not, I don't know. You could rewrite 4 as 2 squared if you really wanted to, and then pull the 2 out front. I think that's debatable about whether that's any better. If you guys all, I think that's debatable about whether that's better or not. I understand that is something you could do, but whether it's more simpler, I don't know. Okay, I think natural log of 4 plus 5 is perfectly fine. Okay, so questions on any of that now that we can see the answer there? Thank you, Brian. So, all right, let's continue on then here. All right, so another use of this is in expanding, or another application that we'll be doing is just expanding the logarithm. I don't know why I did Roman numerals. Okay, so expanding. Okay. So essentially what this does, what we do here is we take a logarithm that's nice and neatly together, and then we just break it up as much as we can, kind of like we just did. Okay, so for example, like log base 10 of 5x cubed y. Okay. 5x cubed y. So you can see we have a product of three things, and so that product of three things, we can just go ahead and make it a product of, or a sum of those three things. So log base 10 of 5 plus log base 10 of x cubed plus log base 10 of y. You just break up the product there. Okay. The one other thing we could potentially do here to kind of like use one more property. What's one other thing we could do at this step now to kind of use one more property that we have? Or what could we do? Yeah. Exactly. Take the exponent of 3, bring it out front. And of course, since it's only the x that's being cubed, it's only going to go in front of the log of the x there. So it'll just be still log base 10 of 5 plus 3 log base 10 of x plus log base 10 of y. That 10 and that 5, right, it's really tempting to try and simplify that. But they don't, because again, 10 to what power would give us 5? There's no nice number there that we could do. Okay. There's no nice number there that we could use. So we just leave it. Log base 10 of 5. Okay. Let's try another one here, and then I'll have you all try one. Let's use natural log of 20 times the square root of x over y. So in the first example, we were able to kind of break it up all at once, right? We can just say it's all one big product, so we'll just break it up using addition over the product. Here, maybe we want to hold off on that, right? Because now we have a lot more going on. It could be rewritten as one big product again, just as we had in the previous problem, but it's not currently in that stage. So let's take it piece by piece here. Okay, the biggest thing I see right here is that we have the 20 and it's being multiplied by the square root of the x over y. So we can break this up into the natural log of 20 plus the natural log of the square root of x over y. Right, that was a product, so now it's addition. Okay? Now, that square root, what exponent is that? It's the 1/2, right? So we can rewrite this further. Instead of the square root of x over y, we can say it's x over y to the 1/2, which means now what can we do with that 1/2? Bring that out front, right? Its exponent comes out front. Yes, it is. Okay, and by similar token, cube root is 1/3, fourth root 1/4. Okay. Now we have x divided by y, which we can change to what? Subtraction. You got it. And that 1/2, again, it's going to be 1/2 times the quantity, natural log of x minus the natural log of y. Okay, so again, you can distribute if you want, or you can leave it like that. It's up to you, okay, whether you want to distribute the 1/2 or not. Okay. Again, natural log of 20, technically you could break that number 20 down into like 4 times 5 or 2 and 10, whatever, but again, I think it's debatable about whether that's, right or not. I think you can leave kind of a number kind of together, okay, unless you see it can be simplified further. But natural log is log base e, and we can't really rewrite 20, using powers of e and stuff like that, so, or not easily at least, so we'll just leave it like this. Okay. So questions on any of that? All right, let me have you guys try one then. So you guys try this one. I'll give you another natural log. Natural log of the square root of 3x plus 5 all over 7. the natural log of the square root of 3x plus 5 all over 7. All right, so any ideas here about how we can proceed? Yeah, Brian? All right, very good. So we have that division there, right? That's kind of like the big operation that we're doing here inside that logarithm, right? It's division, the top and the bottom. So we can then break that up into subtraction, right? So it's square root of 3x plus 5 minus the natural log of 7. And then, anything else we can do here? So 3x plus 5 is to the 1/2 power, so let's see how I'll do that, yeah. And then that 1/2 you want to bring it out front, I'm guessing, right? Okay. All right. Did you do anything else? Good. Okay, 3x plus 5, right? We can't break it up. Even though there is a product in here, right? That's 3 times x. Can't be broken up because you can't get to it because it has that 5 being added to it. Okay, so 3x plus 5, you're done there. It doesn't go any farther. Right? Yes, there's a product of 3 and x, but because you have that plus 5 there, you can't get in anymore. Okay. So we can we can expand. We can also then condense too. So in other words, we're going to basically begin a situation like our answers that you see here, and then be asked to put them back together into a single logarithm. Okay, so whereas expanding, the directions are kind of like uncertain. How far do we really need to expand, kind of thing. With condensing, it's a little bit more clear about, you know, our goal. We want to take something that has multiple logarithms and bring it all together as one logarithm. Okay, or condensing, but well, whatever, condense. Anywho, so let's take a look at an example of that. So for example, if I have like 2 log base 4 of x, and I'm adding to that log base 4 of 5. And again, we want to rewrite as a single logarithm. So, for example, I see a 2 here in front of this log base 4. What can we do with this 2? If it's 2 outside of a logarithm, what can we do with that? Yep, put it as an exponent. Exactly right. Bring it up inside as an exponent. Is that what you're going to say too, Brian? Yeah, exactly right. Okay, just like that. All right, and now that we have a sum of 2 logarithms, how can we combine those together as a single logarithm? What should we do? log base 4 of what? Multiply them together, yeah, 5x squared, or x squared times 5, but. Okay, and there's our answer. That's it, we're done. We've combined them all together as a single logarithm. 5x squared. Okay, let's try another one. 1/2 the natural log of 5 minus 3 natural log of x plus 3. Well, again, we have those coefficients, the 1/2 and the 3. So both of those we can kind of put up into the exponents, right? So I'm going to make it natural log of 5 to the 1/2 minus the natural log of x plus 3 to the third there. Okay. We should make that more obvious. That. Okay. And in a way, I should be kind of. Maybe I'll use a second. There you go, something like that. Because I don't want to get us confused and thinking that we're going to cube the natural log. No, we're just cubing what's inside the natural log there. So that's why I'm going to do that. And then, of course, subtracting between two logarithms becomes what? Division, right? Division. And so this is going to be then just the natural log of the square root of 5 over x plus 3 cubed. Like that. Okay. Pretty straightforward, right? No, not too bad, not too bad. What if I changed it up just a little bit here, though, and what if I had, in addition to this, I added a natural log of x on the end like that? I added it on the end like that. So in other words, I would still do kind of the same thing I did here, right? I still have the coefficients, the 1/2 and the 3, they would go up and become the exponents here, but I'd still have this like little plus ln of x in there. And so I've got subtraction, that means to divide, but I've got addition, that means to multiply. So you can kind of do it in steps, if you'd like. One way you can kind of think about this is to do it in steps. You know, left to right. Think order of operations, right? So if you go left to right here, you would do this minus this, so that would become the division. So we'd have that again, and we just kind of bring that plus the natural log of x along for the ride. And now we have this quantity, right, or natural log of this plus the natural log of x, and addition means to do what? Multiply those two things together. So in other words, it would look something like this. Right? It's multiplying them together. But of course, we can put that all together as one fraction. Just make it x times the square root of 5 over, x plus 3 to the third, like that, right? So in other words, the x would go up in the numerator, right? We're not actually dividing. Even though this plus natural log of x is after some subtraction, but it's plus natural log of x. Okay? So that means it's going to go up in the numerator here. Okay? And multiply, so it goes up into the numerator there. Bless you. If we slightly change this, and if I added like parentheses right in here, if I add parentheses in here, then that x and the x plus 3 would get, or the x and the x plus 3 cubed would get multiplied together, but then since it was subtracting the quantity, that whole quantity would go kind of down in the denominator then. Okay. But since the only thing being subtracted here is the x plus 3 to the third, that's the only thing that goes in the denominator. The other things are getting multiplied up into the numerator. Or they go up in the numerator. Kind of the idea. Okay? Alright. Hey. Alright, very good. Thank you. Okay. so there's that. And then I got one more thing I want to show you guys, and that's how to, I'm going to finally show you how to calculate these things using your calculator too. How you can use your calculator to evaluate logarithms, okay? And that is called changing bases. So this is like a bit of a gear shift, just for, real quick though. Okay, and this shouldn't take just like a minute here. Okay. So, the problem with evaluating something like log base 2 of 32 in our calculator, right, is that our calculator does not have a log base 2 button, right? We've got log, which is log base 10, and we've got natural log, which is log base e. We don't have log base 2, right? Which seems kind of like an oversight on your calculator's programmers, right? I mean, it's like, why would you exclude other logarithm bases, you know, when you're clearly going to have those kind of things? Now, obviously, we know the answer to this. What is the log base 2 of 32? It's 5, right? Because 2 to the 5th will give you 32, okay? But still, it's like, man, that seems so easy for us to do. Why can't our calculators do something like that? Well, they can, okay? Here's how you do it. You have to change the base. So the reason why our calculators don't have buttons for log base 2, log base 3, and all that stuff is because it'd be too much, you know, to have that many buttons. So instead, we take this log base 2 of 32, and we're going to rewrite it in terms of another base, equivalently, right? So the same value. So it turns out that log base 2 of 32 is the same thing as saying log base 10 of 32 over log base 10 of 2. Or, it's the same as the natural log of 32 over the natural log of 2. Or, it's the same thing as saying log base A of 32 over log base A of 2, where A is, you know, whatever number you want it to be, really. Okay? So now if we go to our calculators here, and I'll just show you this real quick. Alright. I can type in log, which is log base 10 of 32, make sure you close the parenthesis, divided by log of 2, again make sure you close that parenthesis there, and what do you see? You get 5. Okay. I can do natural log of 32, divided by natural log of 2. 5 as well. Okay? So, that is how we can evaluate other logarithms in our calculator. Okay, that's how you can evaluate other logarithms in your calculator. So then, for example, if I wanted to evaluate log base 4 of 30, right, 4 to what power gives us 30? Well, I have no idea. Okay, I could instead say log of 30 over log of 4. Or I could say the natural log of 30 over the natural log of 4. Okay, we'll get an answer. So log 30 over log 4, about 2.45 something. Or natural log of 30. And again, don't forget to close those parentheses, divide by natural log 4. Same decimal, right? 2.4544, whatever. You know, 4543, 44, etc., etc. The same thing. So I'll round to 3 decimal places. If the directions don't specify, 3 decimal places is a good number to round to. Okay, 3 decimal places. Okay, so that's the help of change of base, which means now we can graph logarithms. So how did I graph, you know, log base 4 of x earlier? Right, when I showed you guys like 4 to the x, and I wanted to show you the inverse was log base 4, all I did was graph log of x divided by, let's see if I can show it here, log of x divided by log of 4. That's how you can graph log base 4 of x. Make it clear. There you go. Okay. So there's that. All right. Questions on any of this? Just want to give you guys time now to practice some of this stuff. So, all right. Let me get you guys started on your assignment then. So here we go. All right. Here we go. And this kind of stuff will be appearing on the quiz. So you definitely want to be ready for that. All right, here we go. Page 241. numbers 15 to 21, 30 to 63, 69, 81. Okay, for all of these, it's every third. Okay, so it's 15, then 18, and then 21, right? It's 30, then 33, then 36, then 39, okay, so on and so forth. And then from 69 to 81, it's 69, 72, 75, so on and so forth. Every third, okay, every multiple of 3. All right. So let's get started on this. Please take a look at this, get started on it, because it's going to be, this is where it starts to get a little tricky, I'd say. You really want to make sure that you get this down, because it definitely gets tricky here.